an example where we try out the box test here. So is the force cy squared j hat, where c is a negative constant with units of newtons per meter squared, conservative or not conservative? And justify your answer. So now we have to do the box test. So our goal is we're going to see if I do this box and add up those four works, do I get a net work of 0? Okay. So I'll note that my force in this case is cy squared j hat, and I'll remember that in order to do work for a force that's changing over a distance, I do have to do the integral. Okay. So for work 1, I'll notice I am moving in the y direction, so I'm going to be doing this part of it. The x component is going to be 0 because there is no motion in the x direction. So I'm going to be integrating the y component of the force. Okay, so that's the one we have. So I'm going to integrate from 0 to 1. And we always like to do 1 just because it's going to work out nice for our math. You could do any numbers you wanted for your box test. We just typically do 1. So then I have cy squared dy. Go ahead, take that integral. We're going to be left with cy cubed evaluated from 0 to 1. And so we're just left with c as being work 1. So we did positive c. C is a negative value, it said, so really this is some negative number here. Okay. Work 2, you'll notice that the force is in this direction and the displacement's in this direction. So this one is 0 joules because my force is perpendicular to my displacement. And so I could probably hop down here and do this one as well because, again, my force is perpendicular to my displacement. Work 3, on the other hand, I'm starting at 1 in my y direction and going to 0 in my y direction. Okay, so I'm going to integrate from 1 to 0 of cy squared dy. And so here I end up with cy cubed. Whoops, I missed something. I missed a 3 over here. That's okay. We'll get it in now. Cy cubed divided by 3 evaluated from 1 to 0. So now I'm going to do the top minus the bottom. So I'm going to have 0 minus c divided by 3 here when I plug in those values. So I have a negative c over 3. And so now just to find my net work, I'm going to have a positive c over 3 plus 0 plus negative c over 3 plus 0. And so this all adds up to 0 joules, which means I have a conservative force. And that's how the box test works. You have to find each individual work, add them up, see if it equals 0, you have a conservative force. A lot of work for kind of a not so great fun answer of 0. Part B wants to know, is the force cy squared I hat, again where c is negative and we're in units of newtons per meter squared, conservative or not conservative? Okay, so let's go through this one real quick. So on the way up, the work is going to be 0 joules because when I have a force that is cy squared I hat, notice the I hat, it is pointing in this direction, displacement's in that direction, so they're perpendicular. Up here, you'll notice that the y value isn't changing. It's a constant, so it's just 1. So up here I have just c times 1. Okay, so I just have a work of c. Again, they're perpendicular over here, so I have 0 joules there. And then on the way back here, my y value is 0 this whole time, so I have 0 joules of work. So if I add these up, does not equal 0. That means it's a non-conservative force. The quick way to tell, quick and dirty, it's not a justified proof by any means, is to look at your force, and if the y component is only dependent on y, there's no x's or z's or anything in here, and the x component is only dependent on x's, there's no y's or anything, then you have a conservative force. So I see that my y or my j hat is dependent on y, conservative. I see that my I hat is dependent on y, not conservative. So that's kind of more the quick way to decipher if it's a conservative or a non-conservative, but you can always rely on your box test. Either I did it kind of quick on this side, or you can do it the long way. There you go.